Injection molding is the primary method used to produce plastic parts today. It's used to produce anything from Legos to car bumpers to plastic forks and allows for high volume, economical production of complex parts. What is injection molding? Injection molding was originally invented in the late 19th century to replace the need for ivory for the manufacturing of billiard balls. It's used to make computer components, cups, car panels, phone cases, plastic forks, and many other items seen in everyday life. Injection molding is ideal for creating high-volume, low-cost identical parts. Injection molding consists of three main components: the injection unit, the clamping unit, and the mold unit. The mold is clamped shut by the clamp, as plastic granules are loaded into the hopper and then gravity fed from the hopper into the barrel, where they are pushed forward by the reciprocating screw down the barrel towards the nozzle and injected into the mold cavity. The molten material then cools inside the mold and is ejected from the mold once this cycle is complete. The cycle can be done many times a minute. The injection unit can be broken down into several small components. The hopper, which holds the thermoplastic pellet material used in the injection molding process, which is gravity fed into the barrel and screw assembly. The barrel is the chamber in which the reciprocating screw is located and the material is melted. The reciprocating screw compresses and melts the plastic material as it moves down the barrel and then presses it into the nozzle. The heating bands gradually heat and melt the material in the barrel as it moves from the hopper all the way towards the nozzle. The nozzle forms a sealed connection between the barrel and the sprue bushing of the mold. The clamping components are much simpler. It has the clamping cylinder. The mold unit is the single most expensive component associated with plastic parts. A good mold can be worth upwards of $100,000, however, it is usable for over 1,000,000 parts at a time. It consists of the sprue, the gates, cavity, vents, ejector pins, and runners. The sprue is the point where the molten material moves into the mold from the injection nozzle. The gates are small points where plastic flows into the mold cavity from the runners. Runners connect the gates to the sprue. The cavity is the negative image of the finished part inside the mold. There are also vents placed that allow air in the mold to escape, as well as ejector pins, which when the process is complete, push the finished part out of the mold. Injection molded parts have many advantages compared to other manufacturing methods. Primarily low part cost, low production time per part, and low material waste per part. They also allow high part-to-part consistency and complex part geometry and attractive curves. Injection molding also allows for extremely high production volume. No manufacturing process is without its downfalls. Injection molding has limitations in material selection and also has high tooling and startup costs associated with it, as the injection molding machine itself can be close to $500,000 and the molds themselves often start at $100,000 a piece. It also makes it very difficult to change design, requires a high production volume, and early commitment to the part design. For more sources on injection molding, please see the links which I referenced.